Hello viewers, in this video lecture we are going to see one topic for the subject theory of computation, and the topic is normal forms of context free grammar from the 4th unit. Objectives are to understand the concepts of simplification of context free grammar, to analyze the different normal forms of context free grammar, to convert the given grammar into Chomsky normal form and Greibach normal forms. Now let us see what is mean by simplification. Normally, the various languages can be efficiently represented by the context-free grammar. So grammar is used to derive a string. But sometimes not all the grammars are not always optimized. That is, the grammar may consist of some extra symbols, some extra non-terminals. These extra non-terminals unnecessarily increase the length of the grammar. So we need to reduce or eliminate these kind of unnecessary non-terminals. Okay. Now, in the simplification process, during the reduction of the grammar, we may use 3 types of simplification. First one is removal of useless symbols. Second one is elimination of epsilon production. Third operation is removal of unit production. First of all, what is meant by removal of useless symbols? So, a symbol can be useless if it does not appear on the right hand side of the production rule. That is, if a symbol is not used for a string derivation, then it is considered as the useless symbol. Always in a production rule, a non-terminal should reach a terminal. So if the non-terminal symbol does not have the terminal symbol in its production, such symbols are considered as the useless symbol. So we need to eliminate this kind of useless symbols by performing the necessary substitutions. Now we can see this production rules. In this production rules, we can see there are some non-terminals are there. Here the variable c will never occur in the derivation of any string. So c tends to AD is the useless. And one more important thing is the starting non-terminal is t. So, but our c can never reach from the starting non-terminal variable t. T don't have the productions in the right hand side including the variable c. So c is not needed. C does not coming in the right hand side of the starting non-terminal. So when we do the derivation, always we will start from the starting non-terminal symbol and we will try to resolve the right hand side. Here c is unused symbol, so we can eliminate the c. Now we can see what is meant by epsilon production. Sometimes in our production rules, we may have the productions like one non-terminal tends to epsilon. These kinds of productions are called as epsilon productions. These epsilon productions have to remove from the grammars. This can be removed by doing the necessary substitutions. First of all, in step 1, we will find out all the nullable non-terminal variables. So the non-terminal that leads to epsilon productions are called as nullable non-terminal variables. And in step 2, for each production, for example in the format A tends to A, and we will construct all the production A tends to X, where X is obtained from A by removing one or more non-terminal from the step 1. Now in the step 3, we will combine the results of step 2 and with the original production, and we will remove the epsilon productions. We can see it clearly in the example. Here we are having the CFG. Our process is to remove the epsilon productions. Here we can see our grammar having productions like X tends to epsilon, Y tends to epsilon. These two are epsilon productions. We have to eliminate it by performing the necessary substitutions on other productions. So X tends to epsilon. First of all, we can take X tends to epsilon. So to remove X tends to epsilon, we have to substitute epsilon for the places for where X comes. So we can take the first production. Our first production is XY s tends to x, y, x. When we apply epsilon to our first x, our production will be, epsilon means it gets eliminated. So our first production will be s tends to yx. Then if we apply epsilon to our last x in the production, then now our s will be s tends to xy. Okay, so when we apply the epsilon productions in other productions, we will get some additional productions for all the non-terminals. Then we are going to apply y equal to epsilon in the places where y appears on the right hand side. So we have to apply y is coming on the right hand side of s. So when we apply y tends to epsilon in the production number 1, we will get x s tends to y gets cancelled, so we will get s tends to xx. Then if we consider epsilon for both x and y, if x and y in the first production, then we will get s tends to x. Then if we consider, we have to substitute for all possible cases. Okay, if both x are replaced by epsilon in the first production, now we will get s tends to y. Now we have to apply all the new right hand side of the s to the old production rule. So now we have reconstructed the s as s tends to s having many productions like all the possible combinations after applying epsilon. So this is the new production rule we got for s. Similarly, we can also apply the we have to apply x tends to epsilon to the second production rule. So we will get x tends to 0. Then if we apply y epsilon to y for the third production, we will get y tends to y. So these new values will be added as the new productions. So finally we will get the new production, new grammar, and that is summarized. That is, first one is the production rule for s, second one is the production rule for x, third one is the production rule for y. So we produced the additional right hand side terms, that is produced by the application of nullable productions. Now eliminating the unit productions. To remove the unit productions, unit production means if the right hand side having only one non-terminal, such productions are called as unit productions. For eliminating the unit production also, we have to do the necessary substitutions. Here in this example, we are having the unit productions b tends to a, and s tends to c is also one of the unit production. So it can be rearranged like, in the place of c, we have to eliminate c, s tends to c. So in the place of c, we have to eliminate the value of c. So s can be reconstructed into s tends to 0a, 1b, 0, 1. Instead of c, we have substituted 0, 1. Similarly, b tends to a is the unit production. B tends to a is the unit production. So we can eliminate, we can modify it for b. So we will get b tends to 1, and in the place of a, we have to put the substitution for a. So we can we can reconstruct the b like b tends to 1, 0s, 0, 0. So we have to substitute the previous production value in the place of a so as to eliminate the unit production. So in this manner we have eliminated the production. That is, in the place of c, we have substituted the value of c, and in the third production we have to eliminate b tends to a. So in the place of a, we have to substituted the production number 2. Now normally the grammar, context free grammar, will have two standard normalization form. First one is CNF, that is Chomsky normal form, and the second one is GNF, Greibach normal form. Both normal forms will have some rules. If a grammar is converted into this particular form, means the grammar should satisfy, the grammar have to rearrange to satisfy those rules. First of all, Chomsky normal form, CNF. Here the A grammar to satisfy CNF form, it should have the productions in this format. First of all, the conditions will be one non-terminal should reach to, in a production, one non-terminal should reach to two consecutive non-terminals. That is, in the right hand side we can have exactly two non-terminals, or we can have the production like non-terminal leads to terminal, like S tends to A, and we can have the production like one non-terminal tends to epsilon. So these three are rules necessary for CNF form. That is, non-terminal leads to two non-terminals, non-terminal leads to terminal, non-terminal leads to epsilon. Now we are having the example grammar. In the first grammar we can see all the rules are in the CNF form. That is, first production rule having exactly two non-terminals, and the second production is having one terminal, A tends to A, B tends to B. But in the second grammar we can see S tends to AA, one terminal, non-terminal. So this is not in the form CNF. So this is example for the grammar which is not satisfying the CNF. Now we can see the example problem to convert the grammar into CNF form, and we can check each and every production rule whether it is satisfying our rules for the CNF form. So in the first production rule we can see S tends to A, which is satisfying CNF. S tends to AA is not satisfying CNF. Also A tends to AB, B tends to AA. All these productions are not satisfying our CNF form. So first of all, we have to do the necessary rearrangements, and before converting any productions, any grammar into CNF or GNF form, first of all we have to do some pre-processings. Like, first of all we have to eliminate the null production, unit productions and useless symbols. First of all we can apply the in the step 1 we have to use a new production by assigning the new starting symbol. So we can use one more starting symbol before our old original starting symbol. So we have to add one production like S1 tends to S. So now S1 is our new starting symbol. In the second step we have to eliminate the null productions. So we all know about how to eliminate the null productions. Simply wherever the null symbol, the null production, the variable leads to null productions appearing, we have to substitute null value for those particular non-terminals, and when we apply the null value, the value gets cancelled. So as a result of the application of null production, we will have some additional terms on the right hand side. Okay. In the second step, we have to remove the unit productions. Like S tends to B is the unit production. S1 tends to S2 is the unit productions. Okay. Now for removing the unit production, for example, we have to remove the unit production S tends to B. So in the place of B, wherever B comes, we have to substitute the right hand side of the B production in the places. That is, the value of B is AA BA. So wherever B comes, we have to substitute this right hand side times in the necessary places. So after this, the grammar will be rearranged into some other format. That is, grammar productions will be varied. After that, in step 4, we will check one by one productions that will not satisfy CNF form, and we will try to perform the substitutions. Here and our production rules like A tends to XBB is not satisfying our condition. A tends to XBB. So A tends to eliminate, to reduce A tends to XBB. So to eliminate A tends to XBB, we will use another one non-terminal R, that is R tends to XB. We will use another one additional production rule, R tends to XB. Now we can substitute R in the place of XB. Now this production rule will becomes A tends to RB, R tends to XB. So now all the production rules will be, all the right hand side will becomes the CNF form. So the condition of the CNF form is, in the right hand side we can have exactly two number of non-terminals and one terminal simple. So in this manner, by using some other extra non-terminals, by performing the substitutions, we should reconstruct our grammar into CNF format. Now Greibach normal form. Here there are some rules are there to satisfy the Greibach normal form. The rules are, we can have one non-terminal tends to terminal simple, and we can have rules like non-terminal tends to epsilon, and we can have the production rules like non-terminal tends to one terminal and any number of non-terminal. These three are conditions for GNF. That is, non-terminal tends to terminal, non-terminal tends to epsilon, non-terminal tends to one terminal following with any number of non-terminals. Now we are going to see the problem for GNF. So the grammar is having the production rules like S tends to A tends to SS, B. Now we have to use the new variables. As per the theorem of GNF, we have to use the new variables. So we are for the given non-terminals. Here in our problem we are having the non-terminals S and A. So we are going to temporarily use new non-terminals in the format of AI. So we are going to apply A1 for S, A2 for A. So we are going to rewrite our production rule with the usage of A1, A2. Now the first production rule will be A1 tends to A2, A1 tends to A. Now we have to compare the subscript of A. We have to compare the subscript of left hand side A and the first non-terminal A. So here the subscript are 1, 2. So the left hand side subscript is called as I, and the right hand side first non-terminal subscript of the first non-terminal is called as J. So here I less than J, so it will be acceptable. Then we will take the next production rule, A2 tends to A1 or A2 tends to B. Here when we compare I and J, here we are getting the condition I greater than J. So this is not accepted. So we have to do some modifications, and we will substitute A1 production in the place of A2. Now what we will get? We are going to substitute the value of A1 in the place in the right hand side of A2 in the production number 2. Now we are getting A2 tends to A2 tends to A, and we will after expanding this, we are getting some 3 right hand side production rules for A2, and after this when we compare A and J, we are getting the condition I equal to J. This is called as left recursion. Again we have to avoid the left recursion, and we have to construct the grammar so as it becomes I less than J. Now to eliminate the left recursion, we have to introduce the new variable B2 corresponding to A2. Now B2 is nothing but B2 will be derived from A2. Okay, the productions other than the first production present in the right hand side of the A2 production will be taken for B2. So B2 will be have the productions A, A1, B. B2 will have the productions like the remaining term, that is A2, A1. When we look at the first production of A2, we have to remove A2. Instead of A2, we are going to use the variable B2. Now, and the remaining terms are, in the right hand side of A2, the remaining terms are A2, A1. So this will be the right hand side of B2. That is B2 is equal to A2, A1. In another one production, we have to include B2 also. So for B2, for the B variable, we will have two kind of productions, one without B, one with B. That is A2, A1 or A2, A1, B2. Now A2 will become, we will, from the old A2, we will remove the first production and we will take the remaining two productions, that is A2 tends to A1 and B, and along with we have to add B2 for these two productions, and this will be considered as two additional productions. So our A2 will becomes A1B. This is taken from the original right hand side of the production, that is A2. Now this 2 will be again added as the extra productions along with B2. Now we have used the additional variable B2. Now we will try to make every rule into the form A tends to AX. Then we will try in different manners, like we will substitute A, equation number 4, that is we will substitute A2 in A1. We will substitute A2 in A1. Now we will get the new A1 production rule with all the right hand side satisfying our GNF form. That is, our condition is right hand side should have only one terminal following with any number of non-terminals. So in this manner we have to substitute the other production rules in some other production rules variables. Finally we have to check whether all the productions have reached our condition for GNF. So in this manner we have to convert our productions into GNF format. Now the possible university questions are: explain the various simplification methods for context-free grammar, convert the given grammar into CNF form, and convert the given grammar into GNF form. Thank you all.